To tell you more about what we've done this year and what we plan to do is Fawna Korhonen. Fawna has been with GSWA for 13 years, most recently as the Manager of Critical Mineral Systems, but joins you here today in her capacity as the Director of Geoscience.
Good morning. Before I begin, I would like to acknowledge the traditional custodians of the land on which we meet today, the Whadjuk people of the Noongar Nation. I'd like to acknowledge their enduring connections to country and recognize that the First Nations people were the first earth scientists of this beautiful land with such perspective, amazing, and complex geology. So as Michelle mentioned, I've had a few different roles at GSWA over the last couple years. I'm here today as the Acting Director of Geoscience, filling in for Simon Johnson. So I've worked really closely with Simon since I've joined GSWA. He was the the manager of the Capricorn Origin, which was a group that I started with back in 2012. And I came in with a really strong background in high temperature metamorphic geology and crustal melting, having worked on migmatite terrains all over the world. And to be honest, I was a little bit nervous about committing to just Western Australian geology. But Simon, ever the optimist, he assured me, nah, the part of the Capricorn we're going to be mapping has been previously described as a migmatite terrain. It's going to be a perfect fit. You're going to love it. So off I went. And I really tried to keep my expectations in check. I knew there were going to be some differences compared to the places I had worked. I've been to some really spectacular migmatite terrains. So this is what I got. A pile of schist. Now, these rocks weren't really that much to look at in the field, but to be fair, they told a really great story. And Simon actually presented this at our Open Day back in 2012. So the rocks are mostly really deformed granites, if you can believe that, and they record the effects of significant deformation more than 30 kilometers away from a major crustal structure that we see beautifully in the geophysics. And if we look at the microscale of the rocks along that structure, they also preserve beautiful brittle ductile deformation. And that's one of the things that I've always loved about geology, this scale and variance. How if you look at the evidence preserved on the microscale, so at the rock or even the mineral scale, and go up all the way through the crust, and now we have access to the lithosphere, that tells us about fundamental geological information. And GSWA collects data sets across all these different scales. So the acquisition and delivery of pre-competitive geoscientific data is what we do. It's what we've been doing for nearly 140 years. So that hasn't changed. But what has changed is that geoscience is now very much at the forefront of many national and global government priorities. And we're going to have the opportunity after my talk to hear how Marawa and Geoscience Australia are addressing these once-in-a-generation challenges, but opportunities as well. So in order for GSWA to best respond to these changing priorities, we have now implemented an internal organizational restructure. And Simon actually talked about this at our Open Day last year, but this is now in place. And this doesn't necessarily change the work that we do, but it does change the way that we think about, prioritize, and present some of our data sets and knowledge. And one of the aspects of this restructure has been the establishment of 3 different high-level themes that each group is working within, and in some cases across. And we're going to be presenting material on each of these themes throughout the day-to-day, whether it's as talks or as sessions, or the material that we have printed out on the posters. And these themes include materials critical for the energy transition, carbon mitigation and geological storage, and hydrogen as a future energy source. Another aspect of the restructure that I have found already really rewarding is that for the first time in years, we have the regional geoscience groups, the mineral systems, and the energy and geological storage groups all working together. And already this is fostering some really great collaborations and new ways of thinking that I think is going to come across really nicely today. So I'm going to spend the rest of my time with you just highlighting some of our recent work in the West Yilgarn. When I was trying to think of some examples to showcase today and going through the list of achievements we've had this year, it was actually really hard to pick something to talk about, and that's a great problem to have. But the West Yilgarn is a very active project area for us, and of course we've been working in the Yilgarn Craton more broadly for decades. So we have a tremendous wealth of information to build off of. The West Yilgarn has been the main acquisition area for all of our large-scale geophysics over the last year. This includes the completion of phase 1 of WA Array, which has already been mentioned, but we're going to hear a lot more about that this afternoon, which is going to be fantastic. We also have the team here with the models that they'll be happy to talk about in much more detail with you, so please take advantage of that. We are also currently in the process of acquiring a high-resolution magnetic survey in the Nerrier terrain to the north, which is one of the oldest crustal blocks in Western Australia. Zooming into the Nerrier terrain for a second, so that's the bit shown in that hot pink. The geophysical survey is outlined in the yellow, and this is a 100-meter spaced airborne magnetic and radiometric survey. We just started data acquisition on that last month, and we expect to release those results in about a year's time. So when we integrate the results of those geophysics with our ongoing mapping and data collection, we expect to get some really good information on the crustal structure, mineralization potential, and how the Nerrier fits in with the adjacent terrains, which is actually pretty poorly understood. In the West Yilgarn, we've also acquired 1,200 kilometers of active 2D seismic lines this year. The first line was in the southwest, 630-kilometer line, connecting the Albany-Fraser seismic line, which was acquired in 2012, with the coast. We've also acquired 2 lines in the Midwest, one going from Geraldton to Mount Magnet, and then one a little bit further south. And we just had our first interpretation workshop last month. So we are in the early days of figuring out what this all means, but it's already shaping up to show us some really great results. These lines were designed to capture a number of key domains. So each of the lines intersects some of the Proterozoic inliers of the Pinjarra origin. They go through the Perth Basin. Line 1 actually goes across some of the Proterozoic basins, which are older than the Perth Basin, goes across the Darling Fault, and then they head into the Yilgarn Craton. So we've got a tremendous data set that's going to tell us not only about the crustal architecture of these different blocks, but also how they fit together. And when integrated with the results of WA Array, we are going to have a high-resolution, world-class data set to be able to interpret the crust through the lithosphere. Okay, so this image just shows the final seismic images from these 3 seismic lines. They are printed on the back there in large format, so if the lighting is right, you can really start to look at some of the details and talk with the team that's here about some of the early interpretations. We will have the opportunity to hear from Charmaine Thomas in the last session of the day on some of her interpretations and thoughts on the seismic lines. But I want to focus a little bit now on the southwest line, there on the bottom. So this map shows the updated bedrock geology map that we released in 2021, and the black line is, of course, the seismic line. And it shows really nicely some of the key features that we were trying to intersect with this line. Going from west to east, that includes the Proterozoic Lewin Inlier. We know that as Margaret River. And I'm sure, that was just a pleasant accident that it ended there. No, it's got amazing things to say. It goes across the Dunsborough Fault, extends into the Perth Basin, and then crosses the Darling Fault, which is one of the longest and arguably oldest and most complicated structures on the planet. It then heads into the southwest terrain, where it goes across a series of supercrustal rocks, and then into a very complicated network of Proterozoic shear zones. And we know that whole little corner there has been highly modified by Proterozoic and younger activity. It then goes into more of an Archean signature, where we see some Archean shear zones and mafic intrusions, and then crosses the terrain boundary, which is there in red, which we redefined in 2021. It then passes through what we call the Korhogen tectonic zone, which is a wide transpressional fault system that has exhumed mid-crustal rocks of mainly granite greenstones up to the surface. So those are pretty highly metamorphosed to granulite facies. It then steps across into lower metamorphic grade and more of the background before crossing the you and me shear zone and then going into the standard Archean granite greenstone at low metamorphic grade and then connecting with the Albany-Fraser. So I know that's a bit of detail, but that's the context for that line, and we're going to test some really great things with that. So keeping those annotations in mind, this slide now shows, again, the seismic results. Again, early days of interpreting this. But what's also shown here in green are the major mineral deposits that this line has intersected. This includes Wheatley, Greenbushes, Boddington, Lake King. And what this is going to give us is a really good understanding of the crustal architecture, but also possibly the geodynamics of a number of key critical mineral systems, which include copper, base metals, lithium, gold, and nickel. So when we integrate, so this map on the right shows the current state of field mapping in the West Yilgarn, which includes a number of 100K map sheets from the you-and-me terrain that we've collected over the last 15, 20 years. And it also shows the updated bedrock map of the Southwest. We are now starting to infill north of that in the Midwest and the narrower terrain with geological field mapping and sample collection. And our intention is to expand but also add new data sets to these areas. So this includes, of course, whole rock geochemistry, and Hugh will be talking more about some of the work we're getting from the lithium in those sorts of analyses. If they're highlighted in green, those are topics that are presented or addressed today. We are also undergoing a pilot study to look at ultra-high precision platinum group elements from selected mafic intrusions. We think that's going to show us something really exciting that we will probably incorporate into further work. We undergo structural analysis, both on the regional scale, but also the micro scale. So if we get down to the nitty-gritties of mineral deformation fabrics, that can help us unravel these complicated deformation histories, particularly along the Darling Fault. We undergo metamorphic pressure temperature studies, which helps inform on the thermal evolution. We are conducting mineralization studies from a number of key deposits. Of course, we're collecting geochronology and isotope work to expand our isotope maps. We are also doing more non-zircon geochronology in order to inform on processes that zircon doesn't capture, whether it's their lower temperatures or rocks that zircon doesn't grow in. And this can include things like the micas, which we can link to fabrics, garnets, which we can link to metamorphic events, and apatite and various ore minerals. We also are looking at mineral chemistry as a pathfinder and conducting analyses of heavy mineral cargo from all the WA array sample sites in order to ultimately build up a heavy mineral map of Western Australia. So in addition to these craton studies, we are also very active in the Perth Basin. We will hear a lot more about the CO2 storage atlas today in session 2, but some of that work includes the compilation and cleaning of well logs, developing the stratigraphic framework, depth mapping, temperature mapping. We are continuing to work on the Proterozoic basins, and that includes the stratigraphy, geochronology, and hopefully more mapping in the future. We are really trying to unravel the structure and the depth of the Perth Basin and how that relates to the Yilgarn Craton. And we are also undergoing soil gas monitoring at key sites in order to try to look at the potential for natural hydrogen and helium. So I think this shows really nicely the fact that, again, we've got our basement geologists, our basin geologists, our analytical specialists, our data integration team, all working together to give us a really holistic view from the surface all the way through the lithosphere. And I can't tell you how exciting this is. So I'd just like to finish on this slide. These are some of our other notable achievements that we've accomplished this year, or things that are in progress. This is not exhaustive. This was my jotting things down, and these were the things that I could have talked to, but obviously didn't have time. But if any of these spark your interest, if you'd like to chat about any of these things in more detail, please find me throughout the day. We've got a number of people here that can also talk to these points as well. So thank you very much for your time. I hope you all have a wonderful day.